Okay, so if you don't want to memorize the unit circle, you can memorize, there's a way to know all the trig function values without memorizing the entire circle with all the signs. So basically what you do kind of need to memorize is this up here. Like, what is the value of pi over 3, pi over 4, pi over 6, pi over 2, but I feel like that one's obvious. But yeah, it should be up there. And then memorize the 30, 60, 90 triangle. So know that 30, 60, 90 triangle, one angle is pi over 3, which is 60 degrees. One angle is pi over 6, which is 30 degrees. And then one angle is 90 degrees, which is this one. This box always means that it's a right triangle. I mean a right angle. And therefore a right triangle. Then you memorize these side lengths. So you should know that the angle opposite of pi over 6 is always 1. And the angle opposite of pi over 3 is always root 3. That's kind of how I remember that pi over 3, root 3. That helps me. And then 1, 2. I mean, you do kind of have to memorize this, but it's not as hard as a circle. And then this triangle, which is a 45, 45, 90. So pi over 4, pi over 4, and then 90 degrees. And the side length for this is just 1, 1, and then square root 2. So if someone asks you, like, what's the sine of pi over 3, if you don't just know it off the top of your head, I would suggest you should just draw these triangles whenever you know you're going to have a trig problem. It doesn't hurt, because eventually you'll start to know some of the values, or you can picture it in your head. So if someone tells you sine of pi over 3, your viewpoint should be this pi over 3. And now we know, like, SOHCAHTOA. So SOHCAHTOA, that's opposite over hypotenuse. So what's opposite of this pi over 3? A root 3. And then what's the hypotenuse? 2. So our answer would be, if I write here, my whiteboard is going to fall over. But this is root 3 over 2. Then same with sine of pi over 6. Sine of negative pi over 6. So if our viewpoint is pi over 6, don't worry about the negative sign right now. Your viewpoint is pi over 6. So look from there. What is the sine of that? So that's opposite over hypotenuse. So that's 1 over 2. But what we're not accounting for is this negative sign right here. So that takes me to my second trick, which is this thing up here. Is it showing? Yeah. ASTC. Now you may be wondering, like, what does that even mean? It stands for All Students Take Calculus. And basically this is a way to remember the signs of each trig function in each coordinate. So here, this tells you, in each quadrant, this tells you which trig functions are positive in their respective quadrant. So in this one, A means all. And then in this quadrant 2, for S, that means all the sine functions are positive, which means sine and cosecant. Like, it's reciprocal. And then this one here is tangent. So tangent is always positive here. And then this is so it's cotangent, and this is for cosine and secant. So this is always positive here. So basically we know that sine is positive here, but that means everything else is negative here. So that's basically how you know. So if we're looking at sine of pi over 6, instead of going pi over 6 this way, we're going negative. So we're looking here. And I would, like, roughly, we would have pi over 6 would be roughly over here. I can't draw it because my whiteboard's going to fall. And basically we know, oh, cosine is positive here. But that means everything else is negative. So sine of negative pi over 6, so our original answer was, for just normal pi over 6, is just 1 over 2. So which is opposite over hypotenuse. But because it's negative, it'll be negative 1/2 because it's negative in this quadrant. So yeah, that's what I do to remember, or try to, like, work through it. You can also do it with these these reciprocal functions, like secant of negative pi over 4. So pi over 4, we know that secant is the reciprocal of cosine. So let's just think about the cosine of pi over 4, which is adjacent over hypotenuse. So that would be 1 over root 2. So then the reciprocal of that would be root 2 over 1. But wait, it's negative. And we know that that secant would be here. Like negative pi over 4 is about here, about halfway through this quadrant. So that would mean that because we have our c here, we know that cosine and secant is positive here. So our answer would be root 2 over 1, or just root 2 for this. So yeah, that's how I remember.